Okay, so we're going to do mixture problems today. So you have noticed we are doing charts, which we've done before, but the charts look a little bit different than before because this time we have an extra row. Okay, before we only had rows for 2 unknowns, and I have 3 extra rows this time. So that first row is your equation. That's normal, right? We have just whatever equation is relevant to our problem. But last time I only had 2 unknowns. But the reason why I have that third row this time is since we're working with mixture problems, we're going to have our 1 unknown and our second unknown. And that third row is going to be the mixture of my 2 unknowns. So I kind of have 2 or 3 unknowns, but I kind of don't. I kind of just have 2 that I'm mixing together, okay? A lot of this is the exact same as the charts we've done before. A lot of this information to fill in these charts, you're going to take it right out of the problem. One of the reasons why these can be a little trickier than the other ones is there is just a lot more information. Okay, I have a bigger chart, which means there's more numbers to deal with, but a lot of it is easier to fill in, okay? So, for the first one, if we read through this, talking about a grocer, this grocer makes a natural breakfast cereal costing $2 per kilogram with dried fruit costing $9 per kilogram. How many kilograms of each are needed to make 60 kilograms of cereal costing $3.75 per kilogram? Okay, so that's a lot of information, right? Okay, but to kind of explain this grocer is making some sort of snack mix, okay? And in the snack mix, he's putting breakfast cereal and he's putting fruit, okay? The cereal that he puts in his mix costs $2 per kilogram. The fruit that he puts in his mix costs $9 per kilogram. When he mixes this together, he wants to make 60 kilograms of his mixture, and he wants his mixture to be worth $3.75 per kilogram, okay? So first thing we're going to do, if you look at the chart, half of it's already filled out for you. Our top equation, we have number of kilograms, so basically the weight of each part times the price per kilogram, okay? That'll give you the total cost. That's nothing new. You would probably come up with that on your own. And then on the left-hand side, we have the cereal, we have the fruit, and then we have whenever I mix the cereal and fruit together. So if we go back through our problem and try to fill in some of our chart, like I said, a lot of this they're going to basically tell you where to put it. So it says the cereal costs $2 per kilogram. So guess what we're going to put on price per kilogram for cereal? $2, right. And then it says the fruit costs $9 per kilogram. Okay, so far so good. And if I keep reading, it says how many kilograms of each are needed to make 60 kilograms of cereal costing $3.75 per kilogram. That part's kind of confusing. That 60 kilograms is referring to when I mix the two together. So my final mixture, I want 60 kilograms. So that weight on the mix, I can put 60 kilograms. And I want my final mixture to be $3.75 per kilogram. Okay? Are you with me so far? Okay, so we made a pretty good dent in our chart. I mean, for the most part. I only have a couple things to fill out. That last column we're going to fill out the same way we always do with our charts, just by multiplying across. So I just need those last 2 boxes before I can fill out the rest of my chart. So those last 2 boxes is basically how much cereal and how much fruit I'm going to need. And I know that altogether I'm going to need 60 kilograms of my mixture. Okay, so we've done this before. We did this last week. I need 60 kilograms total. Some of it's cereal, some of it's fruit, and I don't know anything else about this. So how could I fill in my chart? Okay.
And then 60 minus in.
Good. We're going to say I have N amount of cereal. Okay, I don't know, so we're just going to choose a variable, but I have this much cereal. If there's 60 kilograms total, and N amount of it is cereal, the rest of it's going to be fruit. So we're going to take 60 minus N, okay? And then just like with all our charts, to fill in that last column, we're going to multiply across. So I have 2N, and then I have 9 times 60 minus N. And then 60 times 375 is 225. Okay, everybody with me on the chart? Not too bad. Okay, a lot of it's the same.
Can we use our calculators today?
Yes, you can use your calculators today. Okay, so one of the reasons why today is a little bit easier, a lot of times setting up the equation is the hard part, right? You get your chart filled out, and that's half the battle, and then you've got to figure out how to write your equation. Okay, most of the equations today are going to be set up the same way. Okay, so if we look at our charts, let's kind of interpret what this means. This last column is total cost. So this 2N right here, that 2N is the total cost of the cereal in my mixture. Okay. This 9 times 60 minus N, that's the cost of the fruit in my mixture. Okay, and then this 225, that's the total cost of my mixture. This is how much cereal costs, this is how much fruit costs, and this is how much the whole thing costs. So how could I write an equation to show that? Oh. Tiffany.
2N plus 9 times the quantity of 60 minus N equals 225.
Very good. We're going to add the two parts together. It equals the whole. And then we just have an equation to solve. So if I distribute that 9, I have 2N plus 540 minus 9N equals 225. Combine your N's. We have negative 7N plus 540 equals 225. Subtract 540 from both sides, and we get a negative 7N equals negative 315. Divide both sides by negative 7, and I get N equals 45. Very good. N equals 45. Okay, that's great. That's wonderful. I'm so glad I found out what N equals. But we're done, right? Ready to move on to number 2? No, of course not, right? That didn't answer the question. Right? What was I trying to find?
45 kilograms.
Okay, 45 kilograms. But is that all of my answer? No, because I wanted how much of each. Right?
And 15 kilograms of fruit.
Good. I have 15 kilograms of fruit. And I have 45 kilograms of cereal. Make sure you answer the question completely. And when you're working on your homework, you need to tell me 45 kilograms of cereal and then 15 kilograms of fruit. Because if you just say 45 kilograms and 15 kilograms, I have no idea what you're talking about. Are we talking about 45 kilograms of apples or 15 kilograms of ground beef? You don't know. If you didn't tell me, I'm not going to know. Okay, yes.
Ground beef.
How did you figure out how it reached 15 kilograms of fruit?
Okay, so I have 60 kilograms total, right? That's how much my entire mixture is. And I found that I have 45 kilograms of cereal, right? So if N is 45, then 60 minus N will tell me how much fruit I need.
So
Good question. So just plug it back in.
Okay.
Okay, any other questions on number 1? So much fun. I told you guys. Definitely fun. No, I was going to say
I had
fun.
more fun taking my volleyball test, and that took like 4 hours.
Oh, okay. All right. Number 2. Okay, these ones are kind of the same idea, a little different, but really kind of the same idea. Still mixture problem. Number 2 says how many liters of water must be added to 20 liters of a 24% acid solution to make a solution that's 8% acid. Okay, so to kind of make sense of this one, I have 20 liters of this acid solution, okay? This 20 liters is 24% acid. The rest of it's water, okay? Now, I want to add water to this mixture until it's only 8% acid. So in other words, I'm going to dilute this mixture so it's not quite so acidic. What I'm looking for is how much water am I going to have to add to make it that way, okay? So if we go back and fill in our chart, notice that my equation's already filled out for me. But if I take the number of liters, so basically how much acid solution, how much water, how much of my mixture I have, God bless you, times the percent of acid per liter, if I multiply those together, that will tell me how much acid is in the entire thing, okay? So if we go back and read through this, I know that there are 20 liters of my acid solution. And my acid solution is 24% acid, okay? And then I also know that I want to add water to my acid solution to make a solution that's 8% acid. So in other words, my mixture needs to be 8% acid. Okay, so we took all the numbers out of the problem. Didn't make it very far. I've got a lot of blanks left to fill in. Okay, if this happens, what I would do is go back to the problem. What am I trying to find? How much water? Okay, so what I would do, if that's what you're trying to find, that's probably a good place to put your variable. So liters of water, I'm going to let that be my x. Okay? Now let's see what else we can fill in. I have 20 liters of acid. I'm going to pour in this much water. How can I find how many liters of my final solution there will be? Add them together, right? 20 plus x, x plus 20. That's how many liters of my mixture there will be. Okay, well now I only have one blank to fill in before I can multiply across. The percent of acid in water. How much acid's in water? I hope it's 0%, right? Could you imagine if you're drinking water with acid in it? That would.
I feel like if there's a little tiny bit.
Maybe, but we're gonna assume
Like
maybe in your water. Okay, 0% acid in water. Okay, it's not an acidic solution.
I hope we could
Okay.
smell it before.
And now we're gonna multiply across. Okay, now here, whenever you multiply across, you have to be careful because notice there's percents there. We don't multiply with percents, right? Change it to a decimal. So we're gonna take 20 times 0.24, which gives me 4.8. And then I'm going to take 0% times x, which gives me 0. Very good. And then we're going to take 8%, but it's at 8%. We're going to change it to a decimal. What's 8% as a decimal? 0.08 times x plus 20. Okay, I told you on the last problem. For most of these, you're going to add the top two together, set them equal to the third one. I wouldn't do that automatically. Make sure it makes sense why we're doing that. But for the most part, that's what we're going to be doing. So it kind of gives you a place to start. But let's make sure this makes sense. This is how much acid's in my acid solution. This is how much acid is in my water solution. This is how much acids is in my solution when I pour them together. So does it make sense that I would add these together, set them equal to this? Yeah. So my equation would be 4.8 plus 0 equals 0.08 times the quantity x plus 20. Once you have your equation, then we're gonna go about to solve it. One thing you can keep in mind, if you really don't like working with decimals, we can get rid of those, right? You can multiply both sides by 100 and move all the decimals. So that's kind of handy if you don't have a calculator. So you don't have to worry about the decimals, but since you guys are using calculators, it's probably okay to work with the decimals. So I have 4.8 equals and 0.08x, and then 0.08 times 20 gives me 1.6, and then just solve your two-step equation. So subtract 1.6 from both sides, and I have 3.2 equals 0.08x. Divide both sides by 0.08, and we get x equals 40? Yes? 40 what? 40 liters of water. Very good.
That thing's so weird.
Okay, and always double check. Make sure you actually answered their question and make sure you answered it fully. How many liters of water? That's what X is. That's what I found. Okay, questions on number 2. Okay, I'm going to have you guys try number 3 on your own. Number 3 is nearly identical to number 1, okay? So if you need to look back at number 1 to fill out your chart or to write your equation, please do so, but I want you guys to try that one on your own. Okay, so when you finish in your notes, check and see if you got the same thing as I got on the board. If you did, go ahead and try to start number 4. We will go through that one together, but see if you can start it. If you didn't get the same thing I got on number 3, see if you can figure out what you did incorrectly, or I can come around and help you. Okay, number 4 is really similar to number 2, but there's a couple differences here. If we look at number 4, how many kilograms of water must be evaporated from 84 kilograms of a 5% salt solution to produce a solution that's 35% salt? Okay, so first thing, we're going to have to change a couple of things about our labels. The first one's going to be this kind of the same. We have kilograms of salt or water, just kilograms of liquid. Times, this time instead of talking about acid, we're talking about salt. So times the percent of salt, that will tell me the total amount of salt in each of my mixtures. And just like before, we're going to have a salt mixture. We're going to have a water. And then what I get when I mix the two together. Okay, so we can still go through, fill in some things that we know. How many kilograms of water must be evaporated from my salt mixture? It says is 84 kilograms, and it is 5% salt. Okay, now the difference here is that this time I want my mixture to be a greater amount. I want this to be 35%. So before, where I was adding water to dilute it, this time I'm evaporating the water so it becomes saltier. So instead of having less per kilogram or liter, we're going to have more salt per kilogram or liter, okay? Okay, so going back through just like before, once you take everything out of your problem, out of your what you're given, go back and find what you're looking for. So what am I trying to find in this one? Water, kilograms of water, so we're going to let that be our variable. Okay, now this time, I have 84 kilograms of my mixture. That water, that X amount of water, that's how much water is evaporating. So if I'm evaporating X amount of water, how many kilograms of my mixture do I have? Okay, very good. We're going to subtract this time. 84 minus X. Okay, and then lastly, I need the salt. Assuming this is just plain, pure water, how much salt is in water? 0%. Once again, assuming it's just pure water, is 0%. Okay, and then we can go through, fill in our last column. Once again, keep in mind that we changing our percents to a decimal. So I have 4.5 amount of salt in my salt mixture, 0 for my water, and then 0.35 times 84 minus X for my final mixture. Okay, so I'm going to take, just like before, 45 plus 0, 4.5 plus 0 equals 0.35 times 84 minus X. Distribute your 0.35. I have 0.45 equals 29.4 minus 0.35x, and then we just have our two-step equation to solve.
Where did you get 4.5?
84 times 0.05.
Isn't that 4.2, bro?
Okay, it is 4.2. 4.2, 4.2, there we go. Minus 29.4.
I know you hate when you round.
Okay, so 4.2 minus 29.4 is a negative 25.2 equals a negative 0.35x. Divide both sides by negative 0.35. We should get
72.
72 what? Kilograms of water. Always make sure that's what we were asked to find. I wanted to know how many kilograms of water. That was my
I
answer.
did it different, but I got the same thing.